Good morning. Welcome to Megger East Asia webinar. I am Gavin Kurshungal from Megger, and our topic for today is partial discharge measurement in GIS, presented by Rohit Sen, who is a senior application engineer. Good morning. Welcome to Megger East Asia webinar. I am Gavin Kurshungal from Megger. Today, our topic is partial discharge measurement in GIS, presented by Rohit Sen, who is the Senior Application Engineer, Grid Performance Solution for the Asia Pacific region. This is a live webinar. You are automatically muted to prevent any background noises. During the webinar, if you have any questions, please type into the question box which you can see on the left of your screen. We will answer your questions at the Q&A session. At the end of the webinar, please help us fill in a survey which you can see on the right hand side. We will be sending the presentation materials to those who completed the survey. Attendees will be able to download an attendance certificate after they have finished the webinar and completed the survey. A recording of this webinar will be sent to you in 2 days' time after the webinar. So without any further delay, let's start now. Thank you for joining in today. Rohit Sen, I will pass the time on to you now. Thank you.
Hello everyone and very good morning, and sorry for the delay because there was some network glitch. The voice was not audible. So thank you for your patience, and I'm just sharing my screen again. So just confirm me in the chat box. Can you just reconfirm in the chat box that you all can listen my sound? Am I audible to you? And I can and you can see the screen. Yeah. So thank you for the reconfirmation. Thank you, Gavin, for the introductions. Hello, everyone, and welcome to today's presentation on partial discharge testing of GIS. Myself is Rohit Sen. I'm a senior application engineer in Megger, and I take care of grid performance solutions. So, without any delay, our today's agenda will be a small introduction on power diagnostics, what are the measurement techniques, and what is PD, partial discharge measurements of on GIS overview, sensitivity verification test on GIS as per Secret ATBA 64654, partial discharge maintenance strategies using GIS monitor, case studies, and as well as QA sessions. So when you talk about power diagnostic, you always comes into the mind PD, right? Because partial discharge is the first company offering the first commercial device into the market almost 25-30 years before. Again, Power Diagnostic was the company who introduced first color PRW patterns. Since then, we are providing a various solution on the different assets like transformers, rotating machines, GIS, cables, and more. So, when before we just move on, what is the GIS PD monitoring system, or what is GIS PD in the PD measurement in the GIS? Let's have a view what is partial discharge, because we all know that without moving on the basics, there's no logic on that. So, uh, as per IEC 270, it is a localized electrical discharge that only partially bridges the insulation between conductors and which can or cannot occur adjacent to the conductor. That means whenever there is impurities in your insulation, let's say there's a void, and due to the high voltage stress that exceeds the dielectric strength of the insulation material, so that always have a physical and chemical changes that may happen, which produces that such emissions that can easily detect in different uh, PD ways. That it can be a void discharge, it can be a surface discharge, and it can be a corona discharge. So these are just a few examples, but also when you have GIS, you might have hopping particle as well, right? So the first question is always why we need to do PD, right? Because we are doing various testing in our asset. Like when we talk about GIS, we are already having a gas, and which we always measure the pressure leakage and all and all. And we all know that we always prefer GIS because there's no maintenance is required. Because, but still, when the GIS is energized and over a period of time, the most common reason is the deterioration of your installation asset, long-term degradation of electrical insulation, and once you have a PD and left undetected, it always increases over a period of time because PD is nothing, it's just like a cancer. Once we have it, always get bigger, bigger. It's similar to this that in the GIS, once it have a PD, it will just getting bigger and bigger over a period of time. Result is what if left undetected, it wasn't the insulation conditions, leads to failure, asset work less efficient, and of course, it leads to a total breakdown in your app to the asset of the GIS. So it's a simplified cross section of GIS. So when we talk about an overview of the GIS, we all know that this is your outer enclosure, which is typically grounded. This in the center you have a high voltage conductor. In the center you have an insulation material, right, which create a good insulation between your HV conductor to your ground potential enclosure. So when we talk about is simplified cross section in the GIS, so there is a homogeneous electrical field by design, which is where you have equal, or we can say the electrical field strength is below the critical field strength, but due to some imperfection or some impurities, what happened there will be some inhomogeneous uh, electrical field due to the imperfection, and which create or where this is the point, where the electrical field strength goes above the critical field strength. So this is the point where you have partial discharge inception. So I will just take an example on this because there is a lot of confusion in the market. Somebody says we do electrical method, somebody say we do UHF measurement, somebody say we do acoustic measurement, somebody say we do HFCT, which is the right method, right? So I will just like to explain you the measurement techniques with this a small graph or with the drawing. So on the left hand side, you can see this is my asset under high voltage, and due to some impurities, you can see which is creating some partial discharge. And this partial discharge means that PD that emits some energy, right? So energy can be in different forms. It can be in optical lights, pressure waves, discharge effects, dielectric losses, high frequency waves, chemical effects, and heat. So when you have different types of energy, you have different types of methods, or we can say techniques to capture those. So we typically use optical for optical lights, mechanical for pressure waves, electrical for high frequency dielectric losses and discharge effects, and chemical for the chemical effects. But when you talk about partial discharge on the GIS, UHF and acoustic is the most widely used technique, right, in the GIS, especially on site. So we'll now discuss one by one both technology in upcoming slides. So also those measurements which we have discussed, which falls under electrical and mechanical, are also divided into two different groups. One is conventional measurement, and another is a non-conventional measurement. So conventional measurement means it is an electrical method as well. IEC 60 to 70, where you do the PD measurement daily in terms of peaks per coulomb using the coupling capacitor. So this method is typically done in the factory during factory acceptance test. Whereas when your GIS is assembled and it is on the site, and you cannot conduct electrical method for the routine maintenance and to check your dielectric strength of your material. So there are different techniques, that means UHF technique for the GIS, acoustic to pinpointing it, and third is the HFCT. So when you talk about in the GIS, few people say we only do acoustic measurement. But the problem with the acoustic is it is a second step of measurement. It's not the initial action to be taken on the asset, right? So UHF is always help you to understand in which segment you have a partial discharge, and then to pinpoint it, you can use this acoustic measurements. So when I talk about such conventional, non-conventional measurements, we are always interested to measure some PRPD, right, which is phase resolved partial discharge patterns. So you can see on the left hand side, the right hand side is my PRPD pattern, which help me to identify what type of PD it has in my asset, right? So what is PRPD? So it is a 2D representation of a 3D array. That means if each pulse event is represented by a pixel. This is my pixel table, whose position correspond to its phase shift. That means this is my phase shift and from 0 to 360 of the applied voltage and the apparent charge at which it occurs. So the more PD pulse occur at the same phase shift and its magnitude, there is the magnitude, that means the height, the color pixel color changes to indicate its pulse count. So you have no PD, it's white. If you have some pulse count, it's gray, then orange, and depending on the intensity, the color code is keep changing. So when we talk about partial discharge in the GIS, right, there might be different PD sources that may be present in your electrical asset. So these are the few examples which I like to highlight, which has been taken from one of the technical paper published. So in the GIS, you can see this is my uh, HV enclosure, this is my HV conductor, and this is my support insulator. So there might be some moving particle left in your GIS, some voids in your support insulator. Normally you have a UHF sensors because whenever there is a PD, it will create electromagnetic waves, and which those electromagnetic waves will travel from your PD source to your UHF sensors. Another is acoustic, which help you to pinpoint where you have using the piezoelectric sensors. Also, sometimes you might have a high noise due to EMI. That means some telephone, machines, radar, thyristors, which also typically works in a very high frequency from 200 megahertz to 2000 megahertz. So any types of impurities like poor contact, uh, some sharp edges there, moving electrodes, surface discharge voids. So all those things can easily capture using the UHF, and then later you can use in the acoustic for to pinpoint where it is. So when you talk about a signal PD signal propagation, it's quite simple. Let's say this is your GIS enclosure, you have inbuilt UHF sensors, and this the PD is constituted to some imperfection. So this PD will always create electromagnetic waves which will travel back and forth depend on the design of the enclosure, because GIS enclosure act as a waveguide, right? And those broadband signals will pass through your completely GIS enclosure. So this PD source is created, and this you have an integrated UHF sensor which captures all those electromagnetic waves, and UHF sensor act like an antenna and convert those electromagnetic waves to voltage, where you can measure where you measure the PD in terms of dB microvolt or in dB m. So this were some examples, when you have inbuilt sensors. But let's take an example: you have some old GIS and you want to do a partial discharge, right? Because without PD, you have no idea what's happening in my GIS. So what you will do, you have an option to connect the external sensors on the GIS. On so technically, when you don't have any inbuilt UHF sensors, then you completely depend on the design of the GIS. So if you have a spaces present in your GIS where your two enclosures connected, so it's typically used for unshielded spaces. So retrofitting can be done without opening the GIS, of course. it is not that good as compared to the inbuilt UHF sensors. So when you talk about the UHF sensors, so these are the inbuilt UHF sensors which are typically used in the GIS, which has the frequency range from 200 megahertz to 2000 megahertz. It has best signal to noise ratio and often provided by a GIS manufacturer. So implementation of IFP requires close cooperation with GIS monitor, of course, and these inbuilt UHF sensors are typically given by the OEM itself according to their design. So this was overall basics. What is PD? What are the different measurement techniques? What are the solution when you have inbuilt UHF sensors and all? So you might have a doubt in your question that how we come to know that the number of UHF sensors which has been installed in the GIS are more than sufficient. That means what is the calculation, how the OEMs of the GIS calculate that how many sensors are need to be placed. So there is one document CGRE TBA 654 which gives you the method which makes sure that the number of sensors provided by the OEM are more than sufficient that there is no blind spot left in the GIS, right? So that might be possible that that few someone might have reduced the sensors to reduce the price, but which directly affect your sensitivity when you do the PD measurement in your GIS. So this is known. This is also known as sensitivity verification test. As per the CGRE, it is a two-step procedure which looks like a calibration, but it's not a calibration. So let's move and discuss on this CGRE document. What they told that in sensitivity verification that there are two steps. Step one is done in the factory. So what they do first, they just can do a complete setup as per the IEC 685 60 to 70, and they just put a known defect of 5 PC in the GIS, and they just energize that. Okay, when they energize your GIS, your known 5 PC defect will be captured, and once it's known that it's a completely 5 PC, you de-energize the GIS, and you use at the same time, and at the same time when it's energized, you also capture from the UHF device that's in your GIS. And once you capture, let's say you have applied 220 kV, as known 5 kV defect is equal to what you capture is 30 dB microvolt. Once again you de-energize your GIS, you use a pulse injector. You inject a pulse injector here, and you will increase the pulse injector values, and you will make sure that you will get the 30 dB microvolt values, similar what you got in the IEC 60 to 70. Of course, it has some tolerance of 20% plus minus acceptable. Okay, so once you've done this activity, you make sure that you have that values. Then once it goes to on-site measurements, you use the same pulse injector here, and you just inject that voltage in your GIS and make sure that your the sensors which has been installed in your GIS are more than sufficient, and it captures the signals that are 5 PC and equivalent. So I have injected here. So some pulse, so the electromagnetic waves are traveled here. So it's capturing the value. My electromagnetic waves will travel from here to here. It will capture here. It also pass here. But the problem is the more it travels, that is a high signal attenuation. The signal will get dropped, it get weaker. So there is no thumb rule that what should be the exact value. The only thing is you should get some peak, or you can put some signal that sensor has captured something. So once you have injected from here, your all sensors are capturing. That means even you have a 5 PC of PD happening in your complete environment, it still capture the UHF sensors are more than sufficient that it captures those PD. So this is the one of the image of the pulse injector, right? You connect here, you inject the voltage, and you will just see in the PD monitoring system. So typically, when you talk about the GIS during commissioning, of course, the end consumer and the OEM always ask to conduct HV testing. So once you have a GIS tested in the sections, so you have a test cycle at various voltage level. That means you have a rated, then you get some high percent, that's 120% to see the inception and extinction volt PD. Then again rated, and then again you will reduce the voltages. So so there is a dedicated HV test mode option should be there in your software whenever you have a PD instrument. So this is one of the images of your voltage versus current graph, including inception and extinction voltages. So it is completely automatic adjustment of sync settings. You have a scope view, which instantly get the feedback from the measurement channels. It also records the PRPD pattern as well. You can see these are the HV modes where you have injected the voltage. According to with respect to the voltage, what is the PD along with your PRPD pattern, right? So this completely HV testing mode is there. So when we talk about what are the benefits of PD monitoring system in the GIS, of course, it first thing is capture any defect, any impurities present in your GIS. That means poor quality of material, poor workmanship, poor design, anything will be detected with your PD monitoring system in GIS. So these are the few images. So this is the image of contact problem. So it was creating partial discharge, and you can see this white powder form, which is uh, formed because whenever you have a PD, there is very high chance you get a white color powder. So you have a contact problem. So this is the PRPD pattern for contact problem. This is one of the location where the customer had used some solution over there, and when it was energized, but when the GIS was energized, there was some bubbles inside which was creating voids. So this is the PRPD pattern of the multiple voids with faulty insulated disk. Whereas you have a mobile particle, that means some small particles which has been left inside during commissioning. So when your GIS is energized, it keeps dancing inside. It's known as scooping particles. So you will get this type of PRPD patterns for moving particles. So you can see this is the small video in the GIS lab where we have created such type of small issues. You can see there was small particle dancing right when they are energized inside the plate. So this was the overview that sensitive verification tests, measurement techniques, and also now what should be your PD maintenance strategies, right? So if you don't do any PD measurement, there's no cost involved, but there is a very high risk of failure. So then there are other three methods. One is offline PD, so it is only done during the commissioning charge test. So other two is the online PD test, which is spot measurement. You go there, do the measurement, take the kit, and you go to the various sensors. So in this, you don't get any immediate PD notification. You cannot do the PD trending, but yes, you get condition-based maintenance, flexibility, mobile solution, as well as cost effectiveness. Another solution is permanent monitoring. So it gives you condition-based maintenance, immediate PD notification, PD trending, but not flexible or not mobile solution where you can, remove the system and you can place to any other, right? And of course, it's cost effective. So we are going to discuss on those solution in upcoming slides. So this is the offline for the commissioning where to do online is the spot measurement and permanent PD monitoring. So these are the three maintenance strategies. Whereas once your GI is energized, it typically only follows online PD or the PD monitoring system. So when we do the PD measurement of GIS, whether it's a portable or it's a what we say online monitoring, we always place IPU and FCU. So IPU stands for Input Protection Unit. That means if you have any surge, voltage surge generated in the GIS due to switching, you may experience very high voltage on your UHF sensors output. To protect this, we use IPU, Input Protection Unit. And second is the FCU. FCU is a frequency converter unit. That means whatever the frequency you are getting, it's converted to less than 1 megahertz as per the IEC standards. And it give you the capability of signal transmission up to 80 meters. Second is the disturbance antenna solution. That means, uh, like I like I told you that there's you might have very high noise present in your floor. It can be different types of it can be different types of noise like cellular, radio. So you should have some disturbance antenna or grating fascia which capture those noise-borne signals and just directly eliminate from the measurement. So it is completely IP65 glass which is used during measurements. And this is the online PDMR where which has been used on GIS monitor. So this is a solution for continuous monitoring solution for the PD. It is a part of continuous online monitoring. So it has inbuilt 15 GIS plugin boards, and each plugin board have 8 channels. So it will give you up to 120 measurement with one single monitoring acquisition rack. It is completely temperature control, backup with the UPS, self-monitoring. That means you don't need a manpower to be sit in front of it, and it will, completely manless situation. That's why uh, it is also a great tool for digital substations. We have a sync switching box. So each and everything will be monitored in this acquisition rack. So that is was for indoor. So let's say when you have any outdoor condition where you want to install your GIS monitor system, then we just use PDMR IP65. It is completely IP65 rated. So in completely outdoor conditions, it is also a part of online monitoring system, but it gives you the capability only up to 40 measurement channels. So it is complete. It is also completely temperature controlled battery element with heating and cooling solution, backup with the UPS, and completely self monitoring system. And the main is the controlling rack, which or we can say partial discharge monitoring control rack PDA MCR. So it is a part of continuous online PD monitoring system. So it has completely industrial PC that collects all data through fiber optics network, which is connected between acquisition rack and outdoor rack. It has completely inbuilt PC with touch screen with industrial PC with mouse keyboard to see the drawings or to see the layout, because it's completely centralized interface with one rack with remote access, IC61850 interface, relay output for alarm forward, USB and optical drive, along with UPS, printer, and self monitoring solution with the system. So this is the completely setup of the online monitoring. So this is your sensors, which is in GIS. This is my disturbance antenna. This is my control rack. And as for the sensor, you may increase and decrease this. Acquisition rack, whether it's indoor or outdoor, is completely connected with the FO cable. So even you have any break from any one side, so the ring network always help you to make you sure that it's communicated with each other. So it also have a complete software monitoring view. So that means it just make a complete layout of your complete GIS and customize your GIS layout with the individual sensor labeling and positioning. You can see where the location positioning are. Direct overview about PD activity in GIS and as well as PDMS status. So it also have full monitoring control software with detailed alarm events. If something happening in your system, let's say PD, it's always measure your date and time stamp on each entry. So PRPD for each suspicious measurement can be stored according with the date, time, which phase happened, which UHF sensors happen. So you get complete details along with the PRPD patterns, along with the general events like your system status, connection got loosed, battery got UPS is not working fine. Anything happen, everything will be logged in the software. And the GIS monitor portable, sorry, GIS monitoring system, along with the software, also have a complete software for sensitive verification tests as well as the HV test modes, which we have discussed previously. So you can see the same pattern, uh, it was same snap of the software. It also have dedicated adjustment sync, scope view. It records the data and you can also replace later on recording the PRPD for further analysis, recording the HV level during the inception extinction voltage measurements. So this was the mental strategies online, but now one more strategy has been added, which is temporary PD monitoring. That means what is temporary? That means it gives you the same condition-based mobile solution, flexibility, immediate PD notification, PD trending, and cost effectiveness with the portable one. So earlier we are using portable for only online PD testing, but now portable will also help you for the temporary monitoring. So now let's discuss in the upcoming slide what is temporary PD monitoring and how it's beneficial. So when you talk about the temporary PD monitoring, we are offering GIS Monitor Portable, which is one of the great tool for the temporary PD monitoring. That means this portable instrument will help you to do the partial discharge measurements in your GIS. Spot measurement as well as temporary monitoring. It means you can do the monitoring feature with the same portable kit. So this is the easy setup. You can see this is my GIS monitor portable connected with my laptop, and here my sensor has been connected either with the inbuilt UHF sensors or with the external flex sensors where you don't have inbuilt UHF sensors. So the software is capable for temporary monitoring. You can see you can just connect up to 8 channels and also go up to 40 channels in future where you capture the PRPD patterns. You have a voltage where you do the trending along with date and time along with dB microvolt values. It also capture all the events, each and everything because we are using the same software what we are using for the GIS monitoring system. So the same software is there with the GIS monitor as well. So it gives all the capabilities of the maintenance strategies like trending, monitoring, spot measurement, and all. Along with this, we also have MCI, which is mobile communication interface, which allows for remote access via different cellular network like 3G, 4G, or 5G. So you have monitoring device here, and this monitoring device is connected with MCI, and this MCI have internet which is connected with the cloud or the server, and you can have live monitoring, live observation, live measurement from on your PD monitoring device. So it also have captured all the features like alarm events, internal events, along with date and time of the PRPD pattern, and also the details. It also have full monitoring control software like live mode for operations, software, scope view, deep analysis of PD signals by PRPD patterns and all. It also have dedicated sensitivity test modes, dedicated HU test modes and all. It also have full monitoring software device like HU test modes that what do for the commissioning as well. And the main thing, and we also have an ICM expert software. That means, let's say I'm a new user of PD instrument and I'm not expertise in it. So we have a built-in library in a software like different types of PD patterns has been captured like voids, surface discharge, Hooping particles and all. And all those things are stored in the library. So let's say when I have done some measurement on the GIS, I'll just click on the load. My pattern will be loaded in the software. It will the details what was during measurement. I will just click analyze, and in the analyze it will just compare with the pattern library, and it will just compare with the PRPD pattern, and it will give you the indication that what type of PD source you have in your electrical asset. It's void, surface discharge, or anything. So these are the few PD patterns I would like to show in upcoming slide. What are the floating elements, moving particle, protrusion, and voids. So this is one of the slides of protrusion. This is a single protrusion. This you have multiple protrusions. That protrusion means sharp edges. Mostly the scratches due to the insufficient care during assembly. Often it has very low PD level, but the sharper the tip, the easier to detect because it creates more, PD activity, electromagnetic waves when you have more sharp. So sharp of the PD tip can be changed over a period of time. So you might have a significant polarity effect as well. You have voids. So these are the multiple voids patterns. So voids are difficult to detect during the acceptance test because they might be very small, but over a period of time it will get detected. But GIS manufacturer have implement now X-ray detects to detect voids, but not everybody is doing. But some OEMs also do that as well. So voids are developed over the period of time when the aging effects in your insulator supports. So this was the patterns. Whereas when we say that qualification certificates. So GIS monitor is always a DAWKS dark television certificate is first accreditation in 2003. We have in 2018 we have as per re-accreditation according to ISO 17025. Then we have different ISO certificate date. Also, we are approved and preferred supplier for ABB, Siemens, GE, Conchar, Air Liquide, MR, and others. Also, we have successfully pre-qualification of partial discharge monitoring system for other different countries like UAE in Deva, electricity and water, and Middle East, Saudi Arabia, National Grid, Qatar, Power Grid in India, and more. So I would like to just share you one case study which was recently captured in one of my measurements. So the GIS was 2016 make. It was 220 kV, and during the measurements, the customer has a built-in UHF sensors. So we just connected our RFU and FCU doing the measurements, and we directly used GIS monitor portable 8 channel to capture those measurements. So during measurement, we just find some partial discharge. You can see here it captures the date and time along with the low level, what type of video you have, what is the pulse peak, and this was the pattern what was captured. It was really looks like a prostitution. Then I used ICM expert software to the analysis, and the software also helped me to understand what type of PD you have. So it also captured protrusion. That means there is some sharp edge in the GIS. So we just recommended customer to do the PD monitoring over a period of time, temporary monitoring. So this is one of the image. It was the location was G4.2 where the UHF sensors was captured, the PD. So it was looked like a protrusion or some also like a surface discharge as well, which initiate this PD activities. We have also captured in the next UHF sensors the PD, which was clearly seen in that particular compartment. And just after a few months, where we just suggested to customer to do the trending and monitoring, because earlier also they had some few failures in the compartment, but unfortunately after a few months, the customer had not taken action on the GIS, and you can see it is uh, the image of self-explanatory what happened in the completely GIS system. And so this was almost very costly. So it was in INR, so it's almost 200k USD dollars for the same instruments. So thank you, and this is what I like to conclude my session. So anybody have any questions and any queries, you can just type in the chat window, and we will just read out the questions one by one, and we will get back to you. So we have one question from one of the customer. Which standard we differ for sensitive verification test? So for sensitive verification test, we use CRA 6 TBA 654, which is two-step procedure. One is done in factory, one is done on site. So I'll read down another question. So another question is from one of the customer. Uh, which product is capable for temporary monitoring as well as permanent monitoring? So yeah. So when we talk about temporary and permanent, of course, uh, GIS monitor portable, which I have suggested, where you have the capability to, it captures spot measurements, also temporary monitoring with the same software what we have, because in the software also have sensitivity verification test, HU test modes, and also you can do the trending on that. So next question is from, okay, what protection we used in the GIS from any high voltage source on surge? Okay. So technically, as I mentioned in the presentation, when you have such surge, obviously that you may find some high voltages on the output of the UHF sensors. So we use input protection unit IPU, okay, which is help you to cut off such high transient coming from your GIS during switching and all. So input protection would help you to protect from all those things. So So one more question is from Mr. Abdul Rahim. For portable monitoring system, how was calibration carried out at GIS? Cannot be shut down. Yes, when we say like for GIS, we don't need to take the shutdown because calibration is not required for the UHF measurements. Calibration is a product is a process when you do for for the rotating machine like generators and for transformers. But we don't do calibration in GIS because it is live condition. What you can do, you can just use a pulse injector in one of the UHF sensors, and you can inject some voltages from one point, and you can just see what UHF signals you are getting from another UHF sensors, and you can just take a reference of the voltage what was given by the OEM for the sensitivity verification test. Let's say they suggest 20 volt, inject 20 volt in the UHF sensors and see the compartments capturing in the complete compartment what are the other UHF sensors you have, whether they pick up the signals or not. So, any more questions? Any doubts? I have read out all the questions. Anybody have any questions? Any queries? So I think there are no more questions. So thank you everyone for your for your presence, and we will have a new upcoming webinars also, which will be shared you shortly on your emails. So I guess we don't have any more questions now. So if you have any further questions, you may send us to megahongkong@megger.com. We will having another webinar on next Thursday, 6th July. Topic is oil testing standards and methods of for transformers. The time is same, 10 a.m. Hong Kong time. If you are available, please join us. Thank you everyone, and I like to conclude the session. Thank you.
I guess we don't have any more questions for now. So if you have any further questions, you may send them to meggerhongkong@megger.com. We will be having another webinar on next Thursday, that is the 6th of July, on the topic oil testing standards and methods for transformer. The time for this webinar would be 10 a.m. HKT. If you are available, please join us. You can also visit www.megger.com/webinars to register for this webinar and also for future webinars. Just a reminder, please complete the survey and download the certificate before you go. A recording of this webinar will be sent to you in 2 days' time by email. Thank you again for attending, and we hope to see you again the next time. Goodbye.